How is cylinder volume used in engineering? Imagine a world filled with pipes, tanks, and engines all made of cylindrical shapes. Have you ever wondered how engineers figure out how much space these shapes take up? Well, that's where the concept of cylinder volume comes into play. It's a simple idea but incredibly useful across many fields. The volume of a cylinder measures how much three-dimensional space is inside the shape. To find this, engineers use a special formula. The formula is the mathematical way to calculate the space inside a cylinder. It involves multiplying three things: the number pi, the radius of the circular base squared, and the height of the cylinder. Pi is a constant that is approximately 3.14159. The radius is the distance from the center of the circle to its edge, and the height is how tall the cylinder is from top to bottom. Knowing how to calculate this volume helps engineers in many ways. For example, when designing pipes, they need to know how much fluid can flow through them. The volume of the pipe determines its capacity to carry liquids or gases. If a pipe has a radius of 2 inches and a height of 10 inches, engineers can plug those numbers into the formula to find out how much fluid it can hold. This helps in planning plumbing systems or fuel lines for vehicles. Engineers also use cylinder volume when designing storage tanks. Whether it's a water tank, a chemical container, or a fuel tank, knowing the volume helps decide how much material is needed to build it. For example, a water tank with a radius of 5 feet and a height of 10 feet has a specific volume that tells engineers how much water it can store. This information is vital for safety and efficiency. In construction, cylinders are used for columns and supports. Calculating the volume of these shapes helps determine how much concrete or steel is needed. If a support column has a radius of 1 foot and a height of 12 feet, knowing the volume helps estimate the amount of material required, which saves money and resources. In engine design, the size of the cylinders affects how powerful the engine is. The total space swept by the pistons inside the cylinders is called engine displacement. Larger cylinders mean more space for fuel and air, which results in more power. For example, a car engine with a cylinder volume of 400 cubic inches can produce more power than one with 200 cubic inches. Fluid flow systems also depend on cylinder volume. Engineers calculate how much space is inside pipes to ensure the right flow rate and pressure. This is important for water supply, sewage systems, and even hydraulic machinery. Finally, industries like food and beverage use cylinder volume to design cans and bottles. Knowing the volume helps them maximize storage while minimizing the amount of material used to make the containers. By understanding the size of a cylinder through its volume, engineers can solve real-world problems. Whether it's designing a new engine, building a tank, or creating piping systems, knowing how much space a cylinder occupies helps make smarter, more efficient decisions.